Students, I am Professor Anindya Das from Achievers, and in this particular video we will be dealing with a very important concept in chemical kinetics, and this concept is so important that every year you will face question in both medical and engineering entrance examination from this particular concept. Okay, so this is very important. I am not going into the detailed theory of this concept. We'll just know the concept and we'll try to solve some very interesting problems. So here we'll be dealing with the concept, the variation of half-life time with the initial reactant concentration. Here half-life time is denoted as T half, we all know that, and initial reactant concentration is denoted as A naught. We also know this thing. Okay, so we are already acquainted with these notations. Now the key concept is, this is the key concept. The key concept is, for a first order reaction, that is n equal to 1, the half-life time is independent of initial concentration, and for any non-first order reaction, that is n not equal to 1, the half-life time is proportional to the initial concentration raised to the power 1 minus n, where n is the order of the reaction. Okay. So keeping in mind this particular concept, we will be solving some graphical problems. These are very important. You see, so in short we have, for n equal to 1, T half is independent of initial concentration, and for n not equal to 1, T half is proportional to a naught to the power 1 minus n, where n is the order of the reaction. So let us focus on the first plot. In the very first plot, we find that when we are plotting T half along the ordinate and a naught along the abscissa, we find that T half is a straight line with respect to a naught, and it's parallel to the a naught axis. So what does this represent? It represents that even if we are increasing a naught, as we are moving in the right hand direction, obviously we are increasing a naught, yet T half is not varying, it remains invariant. That means T half will remain invariant with respect to the variation of a naught. That means T half is not a function of a naught. That means the order of the reaction must be 1. So here you can say the order of the reaction is 1. So from this plot we can determine the order of the reaction. So we will be doing the same exercise for these plots also. Okay, so let us move on to the second plot. In the second plot we find that T half is varying linearly with respect to a naught. So as T half is varying with respect to a naught, obviously in this case we will be choosing the second option, that is n not equal to 1. Okay. Now in what manner T half is varying with respect to a naught? It is varying in a linear manner where the y-intercept is reduced to 0 and the straight line is satisfying the origin. We can find that. So if a straight line satisfies the origin, then the fundamental equation is y equal to mx. We all know that. That means y is proportional to x. Here along y-axis we are plotting T half. So here T half becomes proportional to a naught. And what is the power of a naught? The power of a naught is 1. And in the general case the power of a naught is 1 minus n. So obviously we can say that 1 is equal to 1 minus n. That makes n equal to 0. So this is the interpretation. So we get n equal to 0 for this. As simple as that. Now let's move on to the third plot. In the third plot we again see a linear variation, but here along y-axis we are plotting T half, it remains the same, but along x-axis we are plotting the reciprocal of A naught. So here, instead of being T half proportional to A naught, here we have T half proportional to 1 by A naught. T half proportional to 1 by A naught. Because along x-axis we are plotting 1 by A naught. That means T half is proportional to A naught to the power minus 1. 1 by A naught means A naught to the power minus 1. So here the power is minus 1. So now 1 minus n will be equal to minus 1. So 1 minus n is equal to minus 1. That makes n equal to 2. So this is the interpretation, and we get n equal to 2 for this. Okay. Now let's move on to the fourth plot. In the fourth plot, what is happening? We are plotting T half along y-axis and A naught along the axis or the x-axis. And what is this shape? You are already acquainted with this shape. You have studied it in Boyle's law, P versus V diagram. What is this shape? It's a rectangular hyperbola. It's a rectangular hyperbola. And what is the equation of rectangular hyperbola? We know that it's xy equal to constant. See? That means y is proportional to 1 by x. That means T half, you are plotting T half along y-axis and A naught along x-axis, so T half proportional to 1 by A naught. Okay? Because along x-axis we are plotting A naught and along y-axis we are plotting T half. And you don't have to proceed because this is same as the third case. Here also you find T half proportional to 1 by A naught. So it's nothing but n equal to 2. So for a second order reaction, if we plot T half along y-axis and 1 by A naught along x-axis, we will be getting a straight line satisfying the origin. On the contrary, if we plot T half with respect to A naught, then we will be obtaining a rectangular hyperbola. So both these plots represents the second order process. Y-axis remains all the same T half, just the x-axis is different for with respect for plot 3 and 4. Now let's move on to the fifth plot. In the fifth plot we find this sort of a picture. What is this picture? What is this diagram? It's a parabola. What sort of a parabola? It's basically y square equal to 4x. I think you are already acquainted with this. So basically y square is proportional to x. That means y proportional to x to the power half. Now along y-axis we have plotted T half and along x-axis we have plotted A naught. So T half proportional to A naught to the power half. So power of A naught is half. So this 1 by n becomes half. That means n equal to half. So for this reaction, the order is 0.5 or half. Now let's move on to the sixth plot. In the sixth plot, again we are finding a parabola. But here the equation of the parabola is x square equal to 4ay. The parabola has been reversed. So this parabola is defined by the equation x square equal to 4ay. We are already acquainted with that. That means y proportional to x square. So this 2 must be equal to n minus 1. That makes n equal to 3. Okay? Simple? Simple? And now let's move on to the final. Log of T half versus log A naught. You see, T half proportional to A naught to the power 1 minus n. That means T half equal to some constant multiplied by A naught to the power 1 minus n. Or log of T half equal to log of constant plus 1 minus n log of A naught. So this is the equation. And it is given log of T half versus log of A naught. It's a straight line. Making an angle theta. So log of T half, it's basically plotted along y axis. Log of A naught, that is plotted along x axis. So 1 minus n is the slope, and log of constant, another constant, is the y-intercept. So 1 minus n must be equal to tan theta as per the knowledge of straight line. So 1 minus n is equal to tan theta. That means n equal to 1 minus tan theta. So this is the order of the reaction. Now students, there is a trick I have done. Not in this page, in the previous page. Those who have understood the mistake I have made intentionally must be very confused. Can you say in which case I have made the mistake? I have made a deliberate mathematical mistake over here. Let me explain. You have used two different parabolas over here. This one, y with respect to x, and this one, y with respect to x. So in this case, what you find? In the first case, you find two roots of x for a particular value of y. And in this case, you find two roots of y for a particular value of x. So here, for a particular value of y, you are finding two roots of x. So it will be quadratic with respect to x. And here, in this case, you are finding two roots of y for a particular value of x. So it must be quadratic with respect to y. Isn't it so? Isn't it so? Now let's see what we have done. See? We have considered this to be quadratic with respect to y and this to be quadratic with respect to x. Actually, the case should be reversed. So don't get confused. That's why I have made a deliberate mistake over here, so that if you face this problem in the exam, you'll remember my video and you'll not commit this mistake. So for this case, n will be 3, and for this case n will be 0.5. So 0.5 for this and 3 for this. Okay, have you understood? So thank you all and bye bye for now.